More than 50% of the world's population now lives in urban areas, and in recent years, many major cities have been hit with extreme weather events. Vernon Versynen heard from Ian Campbell. He's at the organisation RMI and the lead author of a new United Nations guide on cooling down cities, that large built-up areas may be responsible for exacerbating the impacts of climate change.
There was a question of, well, what are the things that cities can do? Because cities are experiencing heat at a greater level than what we see globally from a warming perspective, just because of the nature of the urban environment. And, when green spaces and blue spaces get replaced by concrete and buildings and asphalt, that form absorbs greater levels of heat and holds on to that heat. So the urban environment gets significantly warmer than the surrounding rural environments or the green and the blue spaces at a rate that can be as much as 5 degrees centigrade warmer. But if you look globally, you're looking at about at least twice the amount of heat gain within an urban environment than what you're seeing in aggregate around the world.
And what would be the consequences of this increased rate of heating in urban areas?
When you have an extreme heat event, you have mortality and morbidity incidents that are occurring. And one of the things with heat and not being able to secure respite from heat is that it impacts human health generally, but it also impacts productivity. And if people aren't able to sleep well at night because of heat, they're going to be less productive during the day.
What have you found are the best methods for cooling down cities and adapting?
There's kind of 3 categories that we put things in. The first is, what can you do from an urban form, urban planning, urban design? You then have another category, which is what are the things that we can do to make our buildings more thermally efficient? And then when you are left with a need for active cooling, what are the things that you can do to ensure that that active cooling is not rejecting further heat into the urban environment? And if you're looking to provide cooling, what are the ways to do that are much less energy and emissions intensive?
So would you say this urban heating effect becomes stronger in places where air conditioning is more prominent in warmer parts of the world?
Yes, and it's one of the unfortunate feedback loops of cooling, because the way that we provide cooling today with air conditioning is very energy intensive. You have not only the indirect emissions associated with the operation of the air conditioner, but you also have the direct emissions associated with the refrigerant. So we know that as cooling access expands, that is going to drive emissions further, and that's going to drive warming, which is what cooling is obviously meant to be countering. But in the urban environment, you've got this other dimension, which is that buildings that have air conditioning are rejecting heat out of those buildings into the urban environment, which adds to the urban heat island effect. And that can add a couple of degrees to nighttime temperatures.
We need better solutions to move away from air conditioners.
Well, there are better solutions, but I think the one I'll share is Paris, and there's an extensive district cooling system there. But they actually utilize the River Seine that flows through Paris as a heat sink. And when it's lower temperatures, they just use that water directly to provide the cooling. And when they have to provide active cooling, they start from the foundation of the lower temperatures of the River Seine as opposed to the temperatures of the ambient air. When you do that, what you're doing is you're not only using much less energy to run the cooling system, but you're also not rejecting heat back into the urban environment, adding to the problem and adding to equity issues.
Would planting trees in urban environments also contribute to cooling?
Planting tree grows in the city of Los Angeles, and they're looking at 5 to 7 degree reduction in temperature just in the immediate vicinity of that area because of the shading and the fact that the tree grove, it's not an urban form that retains heat. That heat energy is used, evaporates moisture, as well as some of that heat is used for the photosynthesis process.